Hello, Professor. Welcome to my assignment 2 Python. So, my name is Kwawin. My student ID 10141849 So, this is assignment 2 that I use pandas, scalar and model selection, TensorFlow, keras model, sequential, dense, and categorical for this assignment. So, I have actually load the dataset from the file name assignment2 iris.csv under the sample data folders that I store in the file name, and then I load the iris the file name, and then I print out the head. So as you can see here, this is the sample width, length, and specie. If you look at the bottom here, specie is Satosa, and the next thing is convert the last column string to integer. That I use first of all I slice it, right, and refer to the last column in the iris data frame, spicy column in my case. So I use the map function to convert the categorical value Satosa, versicolor, Virginica into numeric label 0, 1, and 2, and then I print the head, and now you can see specie is 0, 0, 0 because it's all Satosa, right? And then question number 3, it's asking select the first 4 columns. So here I use the ilog and I slice it again, the first 4 column and the last 4 columns, as you can see here. So I have already run it, and then I split it into the data label into the training testing segment, and y the size of the is 20%. So once again I split it, x train x test, y train y test, train test split, psi 20 and random state 123, right? So the train test split the data into training and testing data set, and x train x test are the input for training and the testing, right? So I printed out here first 5 columns, row x train x test, y train, and y test, as you can see here. Question 4, check the length of the x train x test. So I did it. I actually converted, right? And so here is the length of the x train, which is 120. So which means there's 120 data, 120 row for the x train, and the x test is 30, right? So then convert y train y test from category to one hot encoding. So I use two categorical to convert it to the y train. So typically the one hot encoding convert target label to binary matrix, right? I mean, each class represents like a vector with value as 1 and 0. So typically I have converted both y train and y test, and I run it. And the question 6 is define sequential model that contains 3 dense layer. So here I use the model is 100, right, with the sequential. So typically I create an empty sequential model layer, and the layer will be added one after another. As you can see here, model 100.add dense 100 activation ReLU input shape 4. So this is the input layer. So it's really at the dense layer. So typically it at the dense layer with 100 neurons, ReLU activation, and input shape 4. Since there are 4 input features: simple length, simple width, better length, and better width, right? So and the next thing is ReLU with the hidden layer and the output layer softmax, right? So I have run it here. You can see the models. I compile the models. I use RMS probe, categorical cross entropy and accuracy. So we'll typically use the RMS probe optimizer for better convergence rate. So the categorical cross entropy just specify categorical cross entropy as the loss function. So this is a multi-class classification problem. So typically I use at the same thing that we have studied in the class, for it's easier for me because those things that I have learned, and I think it's pretty much uh, track the accuracy during the training and evaluation, and I think it's fine easier for me. And then I run the history, and then as you can see here, the accuracy here is 0.96, which mean it's almost I think it's almost 100% for that. So 96% 0.66, so which means good. The model with 100 unit and layer, so the test accuracy is 96, which is pretty good. Right, so now I repeat it. So I put the model sequential here again, um, and then I compile it, and then fit, and then I run the history, and then the accuracy is one more time is 80%, so it dropped to approximately 20%. In this case, I think it's not too bad. 20% comparing to 96, 80% comparing to 96. It's still pretty high for me, to be honest. Um, so typically evaluate. So this evaluate. So this evaluate actually calculate the loss and the accuracy of the trained model on the test set. X test and hot test are the test feature label. So this one is good. I think 80% is pretty good for me. So which mean the way I did is not too bad. Um, uh, so for the question, how the number of layer or hidden unit could impact the accuracy of our model. Well, more hidden layer and unit can allow model to capture more complex patterns in the data, potentially improve accuracy. But however, too many layer or unit may lead to overfitting, where the model perform well on the training data but poorly on scene data, right? So this assignment that with 100 models unit, I mean 100 hidden unit per layer achieved 96%, right? As you can see here, while the other with 10 hidden, so this one is the 10, right? As the model with 10 achieve 80% showing more hidden unit helps. So typically more hidden will actually help, right? So do we really suffer from overfittings? It depends, but personally speaking, I think overfitting does not always happen because um, but I mean, it's just common issue in deep learning, right? I mean, yeah, like I said, it depends on the model complexity, data set size, and training duration. Um, and if model have too few parameters, it may underfit, meaning it failed to learn important things, right? So yeah. Uh, how can we detect overfitting? Um, to detect, I think if the training accuracy is high, but the validation is so this one is pretty high, as you can see here. So the value is much lower, the model is likely overfitting, right? So, or we can actually plot the graph too, but it's not asking in the assignment, so I think it's not necessary to plot the graph in here. So if the plot loss curves, like if the training loss keep decreasing but the value loss start increasing, it indicate overfitting. So we can also check the test set performance as well, right? I mean, there is a bunch of way to check it, right? So how can we reduce it? So to reduce it, it's pretty much simple. Just increase the training data, right? More increase the data, reduce model complexity, something like that. So for me, right? So the question use different setting that